To use this method, the terms with the variables must be on the left side and the constants on the right hand side. So if you start with a system that has the x's and the y's and the z's on both sides of the equal sign, you have to isolate them on one side and then put the constants on the other. Make sure that the variables are in the same order in each of the equations. So you can't have x, y, z in one and then z, x, y in the other. So let's go ahead and do a simple problem. X plus y equals 5 and 3x plus 2y equals 12. And our first step is to check to see that the system is in the proper form and write down the augmented matrix. So we're going to strip off the x's and the y's, and we'll be just left with the coefficients on the left, the constants on the right. So I'll end up with the first row being 1, 1, 5, and the second row being 3, 2, 12. Now in step 2, we need to interchange two rows or use multiplication to make sure that the first row, first column, has a 1. Now since this number is already 1 in the first row, first column, we don't need to do anything. We can proceed on to the next step. Now in step 3, we need to add a multiple of the first row to each of the following rows so that the numbers underneath the 1 that we just looked at become 0 in the first column. So in our case, we've got a 3 below that 1, so that means we're going to multiply the first row by -3 and add it to the second row. So in shorthand, I'm going to do -3 R1 plus R2 and put that in place of R2. So below, you see -3 times the first row. There's row 2. So -3 times 1 plus 3 is 0. -3 times 1 plus 2 is -1. And -3 times 5 plus 12 is -3. Now I need to put that answer back into the second row. And so when I do that, now the second row becomes 0, -1, -3. In step 4, I need to multiply or divide the second row by a number that makes the second row, second column, equal to 1. Right now there's a -1 there, so that means that I have to take the entire second row and multiply it by -1. In shorthand, that means -1 times row 2, and I'm going to put that in place of row 2. So below I have -1 times row 2, and when I do that, I get 0, 1, 3. Now I'm going to put that in place of row 2. So now my second row is 0, 1, and 3. In step 5, now we need to multiply or divide the second row by a number and add it to the first row so that the first row, second column entry becomes a 0. So right now it's a 1. So what I'm going to do is take that row that I just modified, I'm going to multiply it by -1 and then add it to the first row. So I'm going to do -1 R2 plus R1 and put that in place of R1. So here is -1 times row 2. Below it is row 1. And when I add those together, -1 times 0 plus 1 is 1. -1 times 1 plus 1 is 0. And -1 times 3 plus 5 is equal to 2. Now I'll need to put that back into row 1. And so now what I see is a matrix that's in what we call reduced row echelon form. And we can now just look at this and see what the answers are. Remember that the first column corresponds to the first variable x, so this first row tells me that x is 2. The second row tells me that y is 3, and so now I have my solution, that x is equal to 2 and y is equal to 3. As the matrices get larger, we're going to have to extend this method to larger and larger matrices. So let's take a look at a new example. In this particular example, we're going to solve the system x plus 2y minus 2z equals 0, x minus y plus 4z equals 3, and x plus 2y plus 2z equals 3. And as before, our first step is to make sure that it's in the proper form and write out the corresponding augmented matrix. Notice that all of our variables are on the left-hand side and our constants are on the right-hand side. So all I do to get my augmented matrix is to just go ahead and drop out all my variables. So I have an augmented matrix. It's 3 rows and 4 columns. The first row is 1, 2, minus 2, 0. The second row is 1, minus 1, 4, 3. And the last row is 1, 2, 2, and 3. So now let's move on to step 2. If necessary, we need to interchange 2 rows or use multiplication to make the number in the first row, first column, a 1. And if we look at this, it's already a 1. So nothing needs to be done. So we move on to step 3. In step 3, we're going to add a multiple of the first row to each of the following rows so that the numbers under the 1 that we just made becomes a 0 in the first column. So the 1 in the second row and the 1 in the third row, those both have to become 0. So let's work with that second row first. So I need to multiply the first row by -1 and add it to the second row. So -1 times row 1 plus row 2, and we'll put that in place of row 2. So here's -1 times row 1, here's row 2, and when I add them together very carefully, I see that I end up with 0, -3, 6, and 3. And now I need to put those in place of row 2. We need to continue. Now we need to put the 0 below, so we'll multiply the first row by -1 and add it to the third row. So -1 times the first row plus the third row. When I add my columns, I get 0, 0, 4, and 3. And be careful about these negative signs. So -1 times -2 is 2. Added to 2 makes 4. That's the most common mistake, is to mess up with your signs. So we end up with 0, 0, 4, 3, and that's what we need to put in the third row. So let's go ahead now and keep moving on. So now we're at step 4. So we need to multiply or divide the second row by a number that makes the entry in the second row, second column equal to 1. In other words, where I see this -3, that needs to become a 1. So we're going to multiply the second row by -1/3, and we're going to put that in row 2. So -1/3 times 0 minus 3, 6, 3. When I make that multiplication, it becomes 0, 1, -2, -1. Now I need to put that answer back into row 2. Now we'll move on to step 5. Now we need to add a multiple of that second row to the third row so that the number in the third row second column becomes 0. Remember, in the first steps we made a 1 and then zeros below it. Now we just made another 1 and now we need zeros below that. But it's already a 0, so we don't need to really do anything. We can move on to the next step. So in step 6, we're going to multiply or divide the third row by a number that makes the entry in the third row, third column, equal to 1. So that 4 needs to become a 1. So we're going to multiply the third row by 1/4 and put the result into row 3. So 1/4 times each of the entries, 0, 0, 4, and 3, leaves me with 0, 0, 1, and 3/4. So now I've put that in place of row 3, and notice we've made 1s, zeros below, 1s, zeros below. We've got a 1 there, but there's nothing below. So this matrix corresponds to echelon or triangular form. For matrices, it's called row echelon form. And we could stop here, get back our equations with x, y, and z, and use back substitution, but we're going to go a little bit farther. So in step 7, we now need to multiply or divide the third row by a number and add it to the second row so that the entry in the second row third column becomes a 0. So this negative 2 needs to become a 0. So I'm going to multiply that third row by 2 and add it to the second row. So here's 2 times the third row. I'm going to add it to the second row. And when I do that, I get 0, 1, 0, and 1/2. And now let's put that in place of the second row. Now we're going to make the entry that's a negative 2, we're going to make that a 0 also. So we're going to multiply the third row by 2 and add it to the first row this time. So 2 times the third row plus the first row gives me 1, 2, 0, and 6/4. And I put that in place of the first row. So notice now when we ran out of zeros below the ones, now we're going to turn around and put the zeros above the ones. So that means in our next step, the 2 that you see here, that also has to become a 0. So to do that, let's multiply the second row by negative 2 and add it to the first row. So there's negative 2 times the second row. We're going to add that to the first row. So negative 2 times 0 plus 1 is 1. Negative 2 times 1 plus 2 is 0. Negative 2 times 0 plus 0 is 0. And now negative 2 times 1/2 plus 6/4, that gives me 1/2. And I put that in the first row. So at this point, now that we have the 1s running down this diagonal portion and the 0s below, this is what we called reduced row echelon form. And we can just go ahead and read off the entries. So the first row tells me that x is a half. The second row tells me that y is also a half. And the third row tells me that z is 3/4. The goal of the Gauss-Jordan method is always to transform that original matrix into a matrix like the one above. That means the augmented matrix with the 1s along the diagonals and the 0s up and above, that's what we call reduced row echelon form. Once the matrix is in that form, then it's simply a matter of reading off those constants on the right-hand side to get our solution.